Okay, good morning, everyone. In this presentation, I will explain about analysis of variance from chapter 12 with study case MIBA. Next, introduction. So in this chapter, we continue our discussion of hypothesis testing. Recall that in chapter 10 and 11, we examined the general theory of hypothesis testing. We described the case where a sample was selected from the population. So in this chapter, on chapter 12, we expand our idea of hypothesis test. We describe a test for variances and then a test that simultaneously compares several means to determine if they came from equal population. Next. So next is the F distribution. It was named to honor Sir Ronald Fisher, one of the founders of modern-day statistics. The test statistic for several situations follows this probability distribution. It is used to test whether two samples are from population having equal variances. And it also applied when we want to compare several population means simultaneously. The simultaneous comparison of several population means is called analysis of variance of or ANOVA. Next. So what are the characteristics of the four distribution? There are five of them. The first one is there is a family of F distribution. You guys can see on the screen on the down below or below. There is relative frequency or degrees of freedom. The second one is the F distribution is continuous and the F distribution cannot be negative. The fourth one is it is positively skewed. And the last one is it is asymptotic. Next. Next is comparing two population variances. So for this material formula is F equals to S1 squared 2 divided by S2 squared 2. And for the critical value, we use the degree of freedom that is N1 minus 1 and N2 minus 1. Next. In here, I will explain about the example and solution or the study case. Next. For the study case is two alternative routes to Quinza Miba store that can be taken by customers are Route A and Route B. Data is collected to compare the travel time on the two routes. Tests at a significance level of 0.10 or 10%. So for the route A, the data was 52, 67, and so on. And for the route B is 59, 60, 61, and so on. Next. And from the data from the previous slide before, we get the solution. First, we state the H0 and H1. That is for the sigma 1 squared 2 is equals to sigma 2 squared 2. And for the H1 is sigma 1 squared 2 is not equals to sigma 2 squared 2. And for the significance level is 0.10. And the formula is alpha divided by 2. So we get 0.05 for the significance level. And for third is the formula, we use the F distribution. And for the fourth is the critical value. To find the critical value, we find first the degrees of freedom. And for the degrees of freedom is N1 minus 1. So the N1 is 7 minus 1. So it's 6. And the N2 minus 1, the N2 is 8 minus 1. So it's 7. Next. Next is the degrees of freedom to find the critical value. So the N1 is for the numerator, 6, and the N2 is for the denominator, that is 7. So the critical value we find is 3.87. Next. So we're gonna determine the sample line for the X bar. So X bar, sigma X divided by N is, for the sample one, for the street A is 52 plus 67 plus 56 and so on, divided by 7 because there is 7 data. So the calculate data and we find the result is 408 divided by 7. So the total is 58.29. And for the S1 is sigma times xi minus x bar square 2 divided by n minus 1. All of the data will calculate by the 58.29, that is 52 minus 58.29 square 2 and so on until the last data is 64 minus 56.29 square 2 and divided by 7 minus 1. So after we calculate all of the data, we got a result is 80.9. Next. Next is same as the sample 1. For the sample 2, we'll calculate all of the data for the street B and divide it by 8. So the result is 59. And for the S2, it's same also for the sample 1. For the sigma times xi minus x bar square 2 divided by n minus 1. So the total of the data is 134 divided by 7. The result is 19.14. Next. Next is the F statistic. So all of these result for S1 and S2, we calculate together 89.9 divided by 19.14 is 4.23. So the decision is to reject the null hypothesis because the compute F value or the 4.23 is larger than the critical value 3.87. So we can conclude that there is a difference in the variance of the travel times along the two roads. Next. Next is the ANOVA assumption. So in another use of the F distribution is the analysis of variance of or ANOVA technique, in which we can compare three or more population means to determine whether they could be equal. So the assumption is, first, the population follow the normal distribution. Second is the population have equal standard deviation. And the last one is the population are independent. Next. The ANOVA test. So there are three tests for the ANOVA. The first one is the total variation is the sum of the squared differences between each observation. The second one is the treatment variation is the sum of the squared differences between each treatment mean and the grand or overall mean. The last test is random or error variation, that is the sum of the square differences between each observation and its treatment mean. Next. Next is the ANOVA table. So you guys can see on the screen that it is the ANOVA table, and I will explain more detail later on the study case that I will explain on the next slide. Next. We're going to move to the example and solution for the study case. Next. So the study case is the manager of Quinzamiba store restaurant wants to measure the level of customer satisfaction with the service of new workers at the restaurant. 3 workers are randomly selected for the next 4 days to be assessed. The total customer satisfaction for each worker is as follows. There are Stacy, Yohani, and Johanna. For Stacy is 55, 54, 59, and 56. For Yohani is 66, 76, 67, and 71. And for Johanna is 47, 51, 46, and 48. So is there a difference in the mean satisfaction level among the 3 workers? Use the 0.05 significance level. Next. So the solution is we state the null hypothesis and alternative hypothesis. So for the H0 is all of the new is equals, and for the H1 is new 1 not equals to new 2 and not equals to new 3. And for the significance level is 0.05. For the critical value, for the degrees of in the numerator is k minus 1 is 3, minus 1 is 2. And for the degrees of freedom in the denominator is n minus k. The n was 12 and the k was 3. So the denominator was 9. Next. Next is the critical value, same as the previous slide before. So the numerator was 2 and the denominator was 9. So the critical value was 4.26. So we're gonna determine the total variation. For the total average is x bar total sigma xi divided by n is 55 plus 54 plus 59 and so on until the last data for the last workers was 48 divided by 12 because the total of the data and for the 3 workers was 12, and for the result was 58. And for the x minus x bar squared 2 is 55 minus 58 squared 2, and so on until the last data was 48 minus 58 squared 2. So the result for all the data that we calculated was 1082. Next. Next is we're gonna determine the treatment variation. So for the Stacy, for the total average is 55 plus 54 plus 59 plus 56. It is 224 divided by 4 because there are 4 data for the Stacy. It is 56, and for the Yohani is 66 plus 76 plus 67 plus 71 divided by 4 is 70. For the Johanna was 48. And for the treatment variation was sigma n times x bar 1 minus x bar total squared 2. So the sigma n was 4 and x bar 1 is 56 minus 58 squared 2, and so on until the last data was 4 times 48 minus 58 squared 2. So the result was 992. Next. Next is the random or the error variation. For the formula is sigma times x1 minus x bar I squared 2. So the result was 90. And all of the result from the data before, we put under the ANOVA table. For the search operation treatment, and sum of square is 992, and for the error was 90. So the total is 1082. For the degrees of freedom is 3 minus 1 is 2, and 12 minus 3 is 9. So the total is 12 minus 1 is 11. For the mean square, for the sum of square treatments is 992 divided by 2 is 496. And for the error, 90 divided by 9 was 10. And for the F is, we'll calculate the mean square is 496 divided by 10 is 49.6. Next. Oh, before I will say thank you. For the conclusion for the ANOVA table was the compute value of F is 49.6, which is greater than the critical value of 4.26. So the null hypothesis is rejected. We conclude that the population means are not at all equal. At this point, we can only conclude that there is a difference in the treatment means. So that's all from my presentation. Thanks for your attention and have a nice day.